Let's talk about GML. In GML, there's lots of concepts, control statements, and things to work with data, all sorts of features. You can open up the manual and read for hours and get overwhelmed by all sorts of features. Hopefully, by now, you're familiar with the basics, right? You got variables equals a number or string variables that equal, words. Very basic stuff. If checks, if variables equals 5, do something. These are like the core building blocks of programming, just in general. No matter what language you're using, anything resembling a modern language is going to have variables. It's going to have if statements. There's lots of other stuff though. So in this video, I'd like to go through and just explain a whole bunch of random stuff that you have access to in GML and why we use it, what it's for, what problems does it solve, etc. So let's just get into it with arrays. So arrays are a way to store multiple variables in one variable or multiple values in one variable. So why would we ever do that? A hint is if you find yourself doing this. Say we are building a first-person shooter or any sort of game where you have a number of weapons that you have equipped. So like Doom, right? You got 1 is your pistol, 2 is your shotgun, 3 is a machine gun, etc. So you might have variables like this. Weapon 1 equals pistol. Weapon 2 equals shotgun. Shotgun would be a sawed-off shotgun. Weapon 3 equals machine gun, right? And that's not great. Anytime you see yourself numbering your variables, that's an array. There's no reason to keep this as separate variables. So how do we make an array? Well, it's pretty easy. You can just, pro tip, hold Alt and Shift, and you can use the arrow keys to select multiple rows and columns and type on all of them at once. There, I just made an array. That being said, arrays are zero-based. So we don't want weapon 1, 2, 3. We want weapon 0, 1, 2. So there we go. We now have our weapon. When you make an array, it's good to make your variable plural as it's going to contain multiple values. So we have our weapons. 0, 1, 2 is pistol, shotgun, machine gun. So I could say current weapon equals weapons 0. Quick terminology shout out. We call this sub. So weapons sub 0, weapons sub 1, and weapons sub 2. And yes, I'm saying that like the Mortal Kombat character Sub-Zero. So it's just a quick terminology, or we also call this an index. So weapons index 0, weapons index 1, etc. So yeah, I could assign my current weapon to weapons 0, and current weapon is going to be equal to pistol. So what's good about an array over a numbered list or set of variables like we had to begin with? Well, lots of things, but primarily let's just look at one example. Say you wanted to have a button like your mouse wheel. Say mouse wheel scroll up, mouse wheel scroll down, changes which weapon you currently have equipped, right? So if mouse wheel up, we'll just do mouse wheel up real fast. We can keep track of which index our current weapon is. Rather than saying current weapon equals weapons 0, we can actually just say current weapon equals 0. And then whenever we need to do anything with our current weapon, like display the name or picture at the bottom, we can say we can just grab our current weapon out of weapons using current weapon. So that's going to go into weapons and grab the name, which is pistol, because current weapon equals 0. So say we have something like this. We can say when mouse wheel up, current weapon equals plus equals 1. We increase current weapon by 1. And if mouse wheel down, we decrease current weapon by 1. And you couldn't do this if you just numbered these variables. You'd have to say if current weapon equals weapon 1, then current weapon equals weapon 2. Else, if current, I mean, you're kind of seeing what's going on here. And this is awful. This is absolute. Can you imagine if you had like 10 weapons like this, and you had to not only handle going up and down, up, but going down as well. Oh, then if your weapon is 2, you need to go to 1. And if your weapon is 1, you need to go back to 3. This would be a nightmare. And so arrays really simplify this. Furthermore, what if you wanted to draw all your weapons out in a bar at the bottom of the screen, like a Minecraft toolbar or Stardew Valley toolbar? Are you going to have a block of code in your draw function that says, okay, draw sprite, weapon, say your weapon here is actually the sprite, sprite pistol, sprite shotgun, etc. We don't need him anymore. Then you're going to be like, okay, weapon 1 sprite or whatever. I guess that would make more sense here. Weapon, then you're drawing weapon 1 sprite at some X and Y, and then drawing this again. Weapon 2 sprite at some X plus 20 and Y. This is, again, can you imagine doing this for 10 weapons, 10 slots at the bottom of your screen? Maybe you can, because you may have done it before. It sucks. It's not fun at all. But with an array, since we can access these with an index, we can instead use a loop to draw all of them. And we'll get to loops in a second, but those are kind of the core features of an array, why we would use one, what they're good for, and what you can use an array even if you don't know how long the array is going to be. Like, yeah, we might have 10 weapons. It's a good time to use an array. We know we've got 0 through 9. We'll never have more weapons than that because the game doesn't have more weapons than that. That's Doom, right? Or Minecraft, how many slots you got at the bottom. You can't increase the number of slots. So that's fine. But arrays are also good if you don't know how many things you're going to have in your array. A good example would be like an inventory list. That, an RPG inventory list, you could have 5 items in your inventory. You could have 100 items in your inventory, 1,000 items in your inventory. An array is good for all of them. And there's tons of functions you can use with an array, as usual, since there's, whenever you've got a feature that you're working with in GameMaker, whether it's a keyboard, a gamepad, anything you're kind of working with, just start typing what it is and then put an underscore after it and see what comes up in your little autocomplete. So I could say array, underscore, boom. There's all of the things we can do with an array. Don't know what one is? Click it, middle mouse, click on it. That'll bring up the documentation. You can read all about it. So as you saw, there's lots of array features, scripts, functions that you can use to work with the data in your array. One last thing before we move on from arrays is how to define them. So let me knock this out real fast. So you may have saw, you remember we just defined our weapon list. So we have weapons 0 equals pistol. I'll do this again because I didn't keep it. And weapons 3, 2 equals machine gun. Okay, that's one way to define an array. That will work. You could, if you wanted to, say weapons equals empty array and then 0, 1, 2. Another way to do it is to say weapons equals, open bracket, pistol, comma, shotgun, comma, machine gun, close bracket. So this is a array literal. So this is ideally how you define an array where you know all the values or how big it's going to be. You just define an array literal, and you don't need to do this like multi-line thing. It's not necessary anymore. So there we go. Arrays, brief overview, very useful. So let's talk more about weapons and what some people might do. So you might say, okay, I've got a weapon. What is a weapon? Well, a weapon has, in fact, we're going to use arrays again because arrays are cool. We've learned how to use arrays. So we're going to put multiple related variables in an array, right? A weapon has a name. In fact, we're just going to call this dude pistol. So we're going to define a pistol. He's got a name. He's got how much damage he does per shot. He's got maximum clip ammo. He's got maximum ammo he can carry. And, you know, this is going to get really confusing. So let's go name and damage and clip size and max ammo. So now we kind of know what each of these represents, and we might go in here and make a real mess of our code. Don't do this, by the way. Just don't. It's not worth it. It's never worth it. You're going to spend so much time spacing things out and lining things up. It's never worth it. Just get used to, yeah, just don't. It's really a waste of time. So what's the problem here? So now, say I shoot my gun and I'm like, oh, I've got the pistol equipped. I'm going to go into my pistol object and figure out what the damage is. So that's going to be pistol sub 1. That's really annoying. And we'll come up, we'll talk a little bit later about macros and enums, and we might say like use an enum to try and make this a little bit easier to read. But we'll give it some sort of name, like, or I mean, I guess we could do that in the variable. Name equals 0. So now I could say name. So pistol name, which is 0, so pistol 0 is our name. And damage equals 1, so pistol damage is 5, because it's our second index, which is 1, is damage, 5. This is not ideal. As soon as you have an array where you can start naming the individual indexes, you should not be using an array anymore. Now you should be using a struct. A struct is it's similar to an array. You've got a variable, a single variable, and you want to put multiple variables in it, but you can actually name these variables as you put it in. So let's make this pistol again, but this time use a struct. Pistol equals open curly bracket. So arrays are open square bracket, structs are open curly bracket. And I'm going to go ahead and close this. We're going to put it on multiple lines too. And you can do that with an array. If you're defining an array, you can put all of them on multiple lines if you want. Not really necessary, but you can do that. So we've got our name. So I can do name and then colon instead of an equal sign. It's not name because we're inside of a struct. These are the rules, right? So name colon pistol. Then comma. Just like an array, we comma. And then damage equals 5. Clip size equals 12. And max ammo equals 200. So we have now just defined a pistol. What's cool about this, what's really cool about this, is up here, if we wanted to access the pistol's damage, we would have to go pistol sub 1, and that's the damage, and we like HP minus equals pistol 1. So dealt 5 damage or whatever. But down here, we can do HP minus equals pistol dot damage. We just dot right into it, get right into that. And this reads so much easier, so much more like English than minus equals pistol dot or pistol sub 1. I mean, you should clearly see the advantage for code readability. Making your code read like English, self-commenting code should always be a goal. So structs are incredibly useful. You can use them in a variety of different situations, but another situation is you might have a bunch of variables that all start with the same name or the same word. An example might be player HP, player max HP, player move speed, player jump speed, right? Or jump power or something like this. When you see that you're doing this over and over again, player, 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 you got a whole bunch of variables that are all starting with the same word, that's a good time to use a struct. Because now you can say player equals HP, 10 or whatever, max HP. I mean, you get the idea. Comma. So now you want to access player HP, just throw a dot in there. And this isn't necessarily the right thing to do all the time, but it's kind of a cool thing to have access to. When you see that you've got these variables all over the place that have the same name, they're all very related. Good time to use a struct. Now we know about arrays, we know about structs. You can combine them. And let's keep running with our weapons inventory example and show you how to combine these. So we have our pistol, we have our weapons array. I can now create an array literal out of this weapons array. So let's get rid of this guy because he's stupid. We don't want to do that anymore. We've already got our structs name. So now let's make a couple of these. Or yeah, let's just make a pistol and let's get our shotgun in here. Clip size is 2. It's a double barrel shotgun, but does a lot more damage, and you can't hold as much ammo, right? So now we have a shotgun and a pistol. So let's define our inventory. So now we have 2 weapons in an array, and inside that array at each index is a struct, which means we can do something like this. What if we want to get the pistol, which is our first 0 index sub-0 value in our weapons array? What if we want to get its clip size? We would go weapons 0, which is our pistol. And again, we might be doing this because current equipped weapon equals 0, right? So we very rarely would be going directly to 0. We'd be, accessing this via a variable. So weapons sub current weapon dot clip size. So boom, right? This is a little mind-blowing. So we've got essentially an array that looks like this. Which is kind of nuts. In fact, this is probably how I would actually set it up. I probably wouldn't have a separate variable that says pistol because it kind of defines itself right here. And that's how you would access each individual property within this giant inventory structure. And you can build these complex structures as deep as you want. A weapon could have a number of ammo types, right? Ammo types, and it could have an array of, armor piercing and hollow point, incendiary, et cetera, et cetera. So now we've got an array with a struct inside of it, with an array inside of it. And you can just keep building the structure out as complicated as you need it to be. And once you kind of wrap your head around how to do this, that you can access these in just the most complex, ways imaginable. But keeping all of your data in structures like this and keeping them all related means that you can access them in a very linear fashion. We're going to go into weapons, at current weapon, grab its ammo type 0. That's going to be armor piercing, which is very helpful. Okay, so we've kind of gone over these arrays and these structs and these complicated structures, and I've made a few references to why we would want to keep them numerically indexed, right? Arrays are really good for, let's go get this guy at 0, at 1. We talked about changing weapons with the plus and the minus to instead of having the named variables 1, 2, 3, now we can access them by number and change our current one by number, and it's easy. So let's talk about loops now and why we would really use these numeric values and get the most out of the fact that we've organized our data like this. So let's say we are drawing out our weapon inventory, as I kind of mentioned earlier. We've got 10 weapons in our weapons array eventually. Well, right now we only have the 2, right? But ultimately for this code, the number doesn't matter. We're going to make it dynamic. But we want to draw out the sprite. Actually, that's another cool thing we could say. We could say sprite equals sprite pistol. Another cool thing to add to our structure. So I want to draw out that sprite for all of my weapons that I have in my inventory right now. So I'm going to do a for loop. So for accepts, like, this is probably one of the weirdest things in GameMaker because there's really nothing else that you format like this. So let me just write it out and then we'll step through it and we'll point out all the different things. So for loops typically have a variable you use to keep track of how many times you've been through the loop. So we haven't been through the loop yet, so we're going to start that at 1. So this is it's underscore I. Typically that stands for iteration, but that's not necessarily, you're not necessarily always going to use an I in this scenario, but we are. So then this is weird, semicolon. So we need to have a separate statement here. And this statement is our condition for if we should continue the loop. So in our case, we only want to loop through our weapons. So while I, which we're going to keep track of how many times we've been through the loop, I is less than an array length of weapons. So we have 2 weapons. So if I is 0, which is what we're going to start the loop on, we're going to execute the code. 0 is less than 2, so we'll run the code again. Then we'll increment this, which is done right here. So what happens at the end of the loop? We're going to increment our I by 1. So then I is 1, 1 is less than 2, we'll do it again, we'll increment it again, and then 2 is less than 2. That's not true anymore, so we'll come down here and continue executing code. So if we were to do this, so this is set up properly now. What did I do wrong? My color coding is broken. No, I guess we don't need that. or yeah, let's just get rid of those. Okay. So how do we use these variables? Well, I'm going to pull out my current weapon is weapons sub I. So the first time through, I equals 0, weapon sub 0, pistol. And we're going to draw that sprite, draw sprite, our current weapon dot sprite. And it's just got a sub 0, and then X, and then Y. Now, if we execute this loop in our draw event, I'm in the create event right now, ignore that. We're in the draw event. Pretend we're in the draw event. If I execute this in the draw event, I am going to draw two sprites. They're going to be right on top of each other, though, because the X and the Y are the same. So I could get the width of these sprites. So sprite get width of web.sprite. And then I can add to this, our X value, our width times our I. And I don't need to put parentheses around this because order of operations will take care of that for me, but it makes people more comfortable sometimes. Always makes me uncomfortable when my color coding doesn't work. I probably screwed something up, but that's okay. I hope that's okay. So now we're going to draw a row of sprites. Not a very impressive row, just two sprites, but if I had 10 weapons in my inventory, they're going to draw all the way across the screen right next to each other since there's no like padding or anything. We're just using the width to draw them out. So again, our width might be 32. 32 times 0 would just be 0. So x plus 0 is whatever x is. Then when this increments up, then we have 1. X plus 32 times 1 is 32. So x plus 32, 64, et cetera, et cetera. So in this manner, we can do anything with any sort of list or that's your primary use case for a for loop is you've got a list, you want to do something on that list. List array, I use interchangeably. I don't use DS lists anymore. Arrays have completely made them irrelevant. So yeah, use arrays for everything. So when I say list, I mean array. They're basically the same thing now. So that's a really good use case for loops. But there are other loops. There's lots of other loops. The two other ones you might come across are while loops and repeat loops. And they're very similar. Like a loop is a loop. We're going to run through some code and we're going to stop running that code at some point under some condition, right? Where we're running through a loop and we're running through a for loop, we're running through a list and we want to know which item in our list we're looking at. So it's a numerical index. That's why a for loop is really good. A while loop, on the other hand, is looking for some sort of condition that typically isn't numeric in nature. One you've probably seen is collision checking. So we say while not place meeting x, y, object wall, x, or x, here we'll do this real fast, x plus 1, x plus plus. So while we're not in a wall, or we're not about to be in a wall, if we check to the right 1 pixel, go ahead and move us 1 pixel. So in this manner, this is going to execute until the place meeting detects a wall 1 pixel to the right, and then it won't execute this code anymore and we'll be out of the loop. So we can do this exact same thing with a while loop if we wanted to. So why would we use a for over a while? Because if we wanted to do it in the exact same way, we'd have to do something like this. Var I equals 0 up at the top, while I is less than array length weapons. Then we can have this code, but then we'd also need to do I++. And this kind of helps you visualize what a for loop is doing, because this is literally going to do the exact same thing. So before we start our loop, we define I equals 0. We only execute the loop as long as this is true. And after we're done executing the code within the loop, we're going to run this code to increment our I. So these two are exactly the same now. So if you're doing this, if you're keeping track of a number and you're incrementing that number and you're checking a condition related to that number, you should just be using a for loop. There's no reason to use a while loop. So there is one other type of loop that is very simple. It's just repeat. And you can give it a number, and you could say, we're going to do the code in here 5 times. It's basically the exact same as copying and pasting it 5 times. Again, you could do a for loop in this same way, and why would you? Let me show you why you wouldn't, because it's the exact same as just doing it up here. People will say repeat loops are faster. It doesn't matter. It's like the most micro of optimizations ever. So don't do it because it's faster. Very, very rarely should you do anything because it is quote unquote faster. So if we have that and we say repeat the array length of weapons, so that's our condition. We know how many items are in weapons. We don't need to compare I to weapons. We know how many there are. So we're just going to repeat this loop that many times. -1. Because we only want, do we want -1? I'll come back to that in a second. But we still need to increment I and run the rest of this code. And again, we got the I increment at the bottom, we're running code. I can't remember if I need the -1 or not. I'm too lazy to think about it right now because I'd like to move on to a usual use case. When would I actually use this? So let's knock that out. And one of my favorite places to do it is spawning particles. So say I want to, spawn 5 particles. Repeat particles create, and it's going to be my part system some x plus random 5, y plus random 5. So I'm getting a different position every time. There's my spark particle, and I'm just going to do 1 because I'm using a repeat loop to do more than 1. So this would create 5 particles around my x and y, well, near my x and y, not really around. And very simple, right? I'm not referencing any sort of, I don't care how many times we've been through this loop. I just need it to execute 5 times. So it's a very simple loop, better than, copying and pasting this 5 times. That would be kind of the code equivalent, which is stupid. So we'll just do a repeat loop. So you find yourself copying and pasting code to do the exact same thing 3 or 4 times in a row. This is probably a good opportunity to use a repeat loop. Okay, we are going to switch gears a little bit now. I'm going to leave this here just in case, but let's move to another event. Not because we need another event, but just to keep this here and in case we need to come back. Okay, so there are 2, well, let's just start with 1. There's another keyword that is really, really useful when you have other objects. So I'm going to say, let's see, object, say object bullet, right? So he's just going to float out there for a second. We're not going to actually do anything with him. So say I've got I'm doing like a shoot 'em up, a space shooter, a bullet hell. And I've got a bomb that will damage or otherwise remove all the bullets on the screen. There's a number of ways to accomplish this, and the best way is probably just instant you hit spacebar, keyboard check pressed, UK space, and this needs to be an if statement. If you hit the space bar, instance destroy object bullet. That's going to go through and destroy all bullets. What if we want to do something a little bit more complex than just destroying the bullets? Let's say for every bullet on screen, I want to destroy it, but then this bomb is special and the bomb creates coins because I blew them up. It turns all the bombs into coins, right? So things are going to be a little bit more complicated now because we want to do something for every bullet on the screen. So that keyword for is kind of important here. Let's use a with statement. So with is, so I can say with object bullet and then code. With is another control statement that will function similar to a loop, but it has its own kind of definition for how long is this loop going to execute for? Well, it's built into with. It's going to execute on every instance of object bullet. If we've got one bullet, it's going to run once. If we've got 100 bullets, it's going to operate 100 times. But what's really cool about with is you are going to run this code as if it was the bullet running this code. So X is not going to be object examples X. It's going to be the specific instance of object bullet, his X, that we're comparing against, right? So if I say instance destroy and don't pass anything, we're destroying that specific instance of object bullet that this code is running on right now. One of 100, one of 1,000, it doesn't matter. We're going to execute on all of them. Of note, you don't really get to control the order they go in, so this is not a good use case if you need to go through all instances in a specific order and execute code. That's rare though. I've never really needed to do that. So this will work for you in the vast majority of cases. So we're going to loop through all the bullets, we're going to destroy them, and then we're going to create a coin where that bullet was destroyed. Instance create depth XY, right? I think that's the right, wow, this is tall. Let's bring that up. XY, yes, I have to look that stuff up sometimes too. Depth 0, or we could use the current depth for the current object, doesn't matter. Object coin, right, which doesn't exist, but you get the idea. So we are creating a coin at this bullet's X, this bullet's Y, and this bullet's depth. So that's really cool, right? But sometimes when you're inside of a with, like let's do this real fast. Let's pretend, let's keep this. We got weapons, right? And depending on the weapon that you destroyed, you had equipped when this this bullet destroyed, we're going to do something different, right? So we'll say if weapon, or current weapon, this is totally nonsensical, but whatever, equals 0, we're going to create a instance of not just the coin, but ammo for that weapon, right? So we'll say, well, it's just ammo, right? We won't get too complex here. We're just going to create some ammo, or increment the current ammo for current weapon. Actually, yeah, let's do that. That'll be cool. So we'll say current weapon equals 0, then increment our pistol ammo. Weapons 0 is really bad, but ammo plus equals 10. We'll add 10 ammo to our current weapon. This is not going to work. A bullet, since we're running this code in the context of a bullet, bullets don't have a current weapon. They don't have an array of weapons. They don't have ammo. They don't have an inventory. They're just bullets. They're stupid. So when we run this code, we say X, this is the bullet's X. Y, this is the bullet's Y. Depth, this is the bullet's depth. Object coin, that's global, right? It would be over here in our list. So of course it has access to it, just like any instance would. But then we get here, and it's like, I don't know what current weapon is. I'm a bullet. I don't have an inventory. So boom, your game blows up. It crashes. So how do we get back out? How do I reference this object example's current weapon and its weapons array while inside of a with? Well, we got a keyword to do that. We can call that keyword is other. So within a with statement, we can use other to get out to the context of our previous previous object that called the with. So we get out here, and now, hey, we have access to current weapon because other, which is object example, has a current weapon, it has a current ammo. And that is your primary use of the keyword other. There's a few others that I almost never use. Like if you have a collision event, you can say collision with object bullet. Other, in this case, is the bullet you collided with. So you could say instance destroy other, right? I very, very, very rarely use these type of collision events anymore. Since I usually put almost everything in step and draw events, and that's about it. So that's another use of other that I almost never use, but it's there. More often than not, when I'm using other, it's because I'm within a with statement. So there is one other way to get variables from this, this step event, this object, into my with statement. And that's using a var. So a var, so if I take var cur weapon equals 0, it's my current weapon, so that would be 0. I can then say cur weapon, right? And then var my weapons equals weapons. And now I don't need other because vars will transcend or move through these the with statement. Just kind of a neat little trick to get variables into here if you don't want to use other, or if you can't use other for whatever reason, or it just makes things overly complex. That's a nice way of passing in a variable. Let's go over one other reason you'd use with. Let's say keyboard check pressed VK space isn't a bomb that destroys all bullets. It is a bomb that destroys bullets that are within a certain radius, right? So we're going to do a little collision checking, a little mathematical collision checking. So again, we're going to say, and we're going to make this a little compound example, so I'll make it even more complicated in a second. When you hit space, we're going to say with object bullet, and we're going to check our distance from our ship. So var dist equals point distance, the bullet xy to other.x, other.y. So our distance from this instance of the bullet to our object example object, which is calling this with. Then we could say if distance is less than radius, which is like, let's say 32, then instance destroy, right? So now we're only destroying the bullets that are within 32 pixels in a circle around object example. So we can make this even more specific. What if this bomb is more like a point defense laser that's going to blow away the single closest bullet? And that's all we care about is one bullet that is very close to us. So we now need to find a bullet that is closer to us than any other of the 100 bullets that are on screen right now. This is where having the ability to pass in a var and manipulate that var within a with control statement is really handy. So let's do that real fast. So I'm going to say var closest equals no one. And this will be kind of cool in a second. Var nearest dist equals a really high number. Like you could do, what's the absolute furthest away any bullet could be? It could be 100, it could be 1,000, depending on the size of your game. I'm going to pick the highest number I know, infinity. Not that it doesn't get much higher than that. And I'll show you how we're going to use that in a second. So we're going to go through all object bullets. We're going to check our distance, and we're going to see if our distance is less than our nearest distance. And if it is, that means it's close. It's certainly closer than infinity. So we're going to capture this distance in nearest. So we're going to update our nearest distance with the distance of this current object, this current bullet. And we're going to keep track of who this guy is. So far, this guy is closer than infinity, and he's like 800 pixels away or whatever. So we're going to capture his distance and his ID. And we'll do this for every single bullet on the screen. And by the time we get through this, we will have a index. Our closest index should be the bullet that is closest to our object. Unless there aren't any bullets. If there aren't any bullets, then this code didn't run at all, but it didn't crash. That's what's really cool about a with. If there's no bullets, this code won't execute, and your game won't crash, which is very handy. So once we get out of here, we can check, did it run? Did we find someone that was a close bullet? So closest, if closest does not equal no one, so at some point we updated closest to equal some sort of ID, then instance destroy closest. That's going to blow away the closest bullet to our object. And in this manner, you can search any number of objects and use any criteria to pick one, or make a list of ones that meet a certain criteria. Like closest could be an array, and you're going to pick, as long as there are three, you can have the three closest. It's a 3-point defense laser that's going to destroy 3 of the closest bullets. Then you can have an array and add IDs to arrays and compare the distances of all the ones that are already in the array. You could do all sorts of cool stuff. And with is what makes that possible. With makes that really easy. Okay, let's change gears again. Let's add another event. So another control statement that we use really commonly is a switch statement. So what is a switch statement? Why would we use it? There's a number of reasons. Let's show a bad example. Let's say I've got a value that is, let's say I picked up an ammo. I picked up some ammo. That ammo is going to have a type on it of some sort. So the ammo type that I picked up, so var pickup equals, this ammo.type, which could equal like hollow point, right? We had those other ammo, we got ammo piercing, armor piercing, hollow point, incendiary, whatever. I'm not going to spell incendiary. Don't ask me to. We picked up an ammo type, and we want to add a specific type of ammo to our list of ammo, right? So we're going to say if pickup equals hollow point, then do this. Then, our ammo under, we know hollow point is 0. Then plus equals ammo dot amount. Else, if pickup equals armor piercing, ammo 1 plus equals ammo dot amount. Else, if pickup equals incendiary, okay, I tried. Then ammo 2 plus equal, this is awful, right? What if you had like 15 ammo types? This is stupid. We don't want to do this. And ultimately, there's a better way to do this completely, but you've got a whole bunch of if else. If this value, notice I double click on pickup, all of these guys light up. So pickup equals something, right? Pickup equals hollow point, armor piercing, incendiary. I want to do something different for each of these, 0, 1, 2. So what do I want to do? I can't just keep doing else if. It's driving me crazy. It's ugly, and I don't like it. So what am I going to do? I'm going to use a switch statement. So I'm going to say switch pickup, and then I'm going to run. I need to say, okay, I want to check for hollow point. I want to see if it's equal to armor piercing. I want to see if it's equal to incendiary. How do I do that? We say case hollow point. And we say case, not current day, case armor piercing. And case incendiary. Now, switches and case statements are a little unusual. So this pickup is equal to hollow point is basically this right here. So what code do we want to run? Where are our brackets? We don't really need them. We can just say colon. So when pickup is equal to hollow point, ammo 0 plus equals ammo dot amount. Then the weird thing about switch statements is we need to tell GameMaker when we're done. That was all the code I wanted to run when pickup is equal to hollow point. So I'm going to use the keyword break and say, we're done with this code. I'll explain what happens if you don't put a break real fast. So we got all of our other things down here. And again, we'd want to break for all of them. And this will do 1, this will do 2. So that looks much better than this series of if statement. Is it less code? Like, is it fewer lines of code? No, it's not. But it's easier to manage, and I think it's easier to read. And if you wanted to make it fewer lines, this is okay. You can do this. That's not going to break anything. I do need my colons, of course. That's not going to break anything. And that looks a lot nicer. So what happens if I don't have this? We've still got our cases, case hollow point, case armor piercing, case incendiary. We're just increasing those ammos, right? We're just executing this line of code. No, we're not. What's going to happen is if pickup equals hollow point, we're going to increase our hollow point ammo, our armor piercing ammo, and our incendiary ammo. It's going to fall right through and just keep executing all of this code. And this ends up being a starting point, not a restrictive, like we're only going to execute this one line. So if I picked up armor piercing, our hollow point wouldn't get increased because we aren't starting up here. We would be starting at armor piercing, increase incendiary. Obviously not what we want. There are some cases where you do want that though. I won't get into them now, but it is possible to have some logic where you want this upper thing to be the same, but or operate again with operate at the same time as another case. And you just say, okay, you know what, when you pick up a hollow point, it's technically armor piercing, so you get both. It doesn't make any sense in this example, but so hollow point will give you hollow point and armor piercing ammo, or you know, maybe this instead of hollow point, maybe this is like a combo ammo. I don't know. It's weird. You're not going to do it very often. And in fact, in other programming languages, they'll sometimes warn you that you've forgotten a break. It's like, hey, are you sure you want to do this? Because it's pretty rare. It's sometimes even just frowned upon in certain coding styles. So just try and remember to get your breaks in there after for each case. And 99% of the time, that's going to be what you want. Okay, so you might notice that this whole, you know, we got an ammo type, and it's a string, and then we're going to an index, and that's kind of silly, right? Like this. In fact, this whole example is silly. I freely admit that if your code kind of looks like this, you've done something wrong. Like this is a lot of code just to, you know, again, we're saying 0, 1, 2, we're accessing these numerically. You know, that's no different than having ammo 0. If we've got hard-coded values in here, we're doing something wrong. So there's no difference between accessing it like that and having it like that. So what can we do to compress this code and make it more readable? Well, we're going to get rid of this idea that ammo types are a string, right? We're comparing pickup, which is a string, to hollow point, which is a string, and that's silly. We shouldn't be doing that. But we still want to keep this idea that these ammo types have names. They're hollow point, they're armor piercing, they're incendiary. Shout me out in the comments if you know how to spell incendiary, by the way, or if I got it right. That would be cool. So what are we going to do? We're going to define an enum, an enumeration. So enum, we're going to call it ammo types. Whether this is plural or not is kind of up to you. We'll talk about that in a second, though. Ammo type, and we're going to have hollow point. Notice this is not a string. Armor piercing and incendiary. Now, this is cool. Now we can say, you know, hollow point, armor piercing, incendiary. First off, we get autocomplete. That's cool. I can say if pickup equals ammo type dot hollow. Oh, there it is, right there. Bam, hollow point. Sweet. So if pickup ammo type equals hollow point. In fact, here let's just go and replace this. Then our ammo 0 plus equals ammo amount. Let's back up a little bit. What the hell is an enum? What does that even mean? Well, it stands for enumeration. And what's enumeration? It means to make a number, assign a number to, right? Give it some sort of numeric value. So what enumeration does is it says, we're going to take these nice names, hollow point, armor piercing, incendiary, and we're going to automatically give them a numeric value. And the automatic is, well, this is going to equal 0, this is going to equal 1, and this is going to equal 2. We don't have to type that out. That's just going to happen. Ammo type dot hollow point equals 0. So now we can just say ammo type hollow point plus equals our ammo amount. And we can do this all the way down, right? Hollow point, armor piercing, incendiary. But you're going to notice something kind of silly is if our pickup is equal to armor piercing, and we're doing armor piercing, well, now we're kind of doing the same thing over and over again. And we've already know that pickup is equal to hollow point. Hollow point is equal to 0. So ammo 0 gets our armor amount. And so as pickup changes, we're just executing different branches of this code, obviously, which means we don't need it. We can just get rid of this. In fact, we can get rid of the F. So pickup is going to equal an ammo type of some sort, and we're just going to say increment my ammo type. So these are really handy when you've got a list of strings that you want to compare things to, or you have a whole bunch of different items and you don't really care what their value necessarily is. You just want them to be unique. I need to know that there are 3 types of ammo: hollow point, armor piercing, incendiary, and that I can uniquely identify them. I don't care that it's 0, 1, 2. I don't care if it's 100, 200, 300. I just want them to be different. That's where an enumeration is useful. Let's look at another example, because we kind of shoehorn this into our ammo thing. A really, really common one is directions. So let's say you've got sprites you've got a direction variable, right? Not the built-in one. Let's call it like face direction or something. Face direction equals east, right? We're gonna face east first, and then if we push up, if we're holding up, then our face direction equals north. And then in our draw event, we're gonna say, we north, east, southwest. We're gonna have a whole bunch of these, and we're gonna loop back around a little bit to our switch statement. So we're gonna switch on face direction and say if case east, then sprite index equals sprite player east, right? And then break, we're going to do that for north, west, and south. And do that over here as well. Okay, so that's another good use for a switch statement. We're switching our face direction based on, or switching our sprite based on our face direction, which could be east, north, south, and west. But what if I did this? What if I accidentally typed north there and it wasn't capital? Then my face direction equals north. I'm never going to hit this. I'm never going to get my sprite facing north. So these are case sensitive. That's not fun. Case sensitivity sucks. I mean, it's important, right? We need it in programming. But when you have strings and you have to remember which one is, did I capitalize north? Did I capitalize east? Was it even north? Did I do something stupid and like spell it without an O somewhere? This is bad. And in other, say I want to draw my cursor or something in front of my player based on which direction they're facing. Now I have to do another switch statement. It's like, okay, if we're facing east, then we're going to say the x of this other object of this cursor, right? Cursor.x equals x plus 30, and cursor.y equals my y, because it's the same y, just over to the right. And then I got to have all these different code. North is going to be my same x, and y is going to be y minus 30. And you're kind of seeing where this is going, and it's really, really annoying. Same y, x minus 30. South is same x, y plus 30. That's so obnoxious, and I don't want to do it. And look, now Now I go back and I fix this capital north. Maybe I accidentally kept this down here, and that's going to break now. Really annoying to maintain, and it's a lot of code, and it sucks. So let's use an enum. Let's use an enum instead. So I'm going to say enum directions, or I like to capitalize my enums because they are global. If you define an enum anywhere in your code, doesn't matter if it's in the begin step event of object example, it's available everywhere by the time your game compiles. So I usually have a script resource out here. It's like script enums, something like that. And you don't even need a function, doesn't matter. You just say, okay, we're going to say enums directions, or direction. Again, it just depends on how you like to read it, whether it's direction.north or directions.north, up to you. I prefer no plural. So then we've got north, south, east, west. And then up here, base direction, we're going to default it to direction east. And then when you head up, it's going to be direction.north. And then down here, I'll fix this in a second, direction dot, let's start with north. Right, that's north. Oh, forgot my capital. But now I got my autocomplete. Dot north, hey, there's north. But I wanted east there. North, west, how do I spell west? Oh, there it is. I don't even have to remember how I spell it. Was it capital W? I don't know. Doesn't matter. It's going to complete it for me. South, boom. So we've now enumerated east, or our directions. So let's jump back here real fast. So north is 0, south is 1, east is 2, and west is 3. In GameMaker, these directions, right, up, left, down, they have numerical values, right? East is 0, north is 90, west is 180, and south is 270. Well, what's cool about enums is even though we automatically get this equals 1, equals 2, equals 3, you can actually do this and modify the values. So I could say north equals 90, south equals 270, east equals 0, and west equals 180. So now I can jump back to my other code, and my face direction is north, sure, but north equals 90. So now when I want to put this cursor somewhere, I can do it mathematically based on my face direction. So I could say cursor.x equals my x plus length year x, length is 30, and direction is face direction. And cursor.y equals y plus length year y, 30, face direction. Boom, that's gone. We don't need that anymore. So now that we can access this as both a named variable that we don't have to remember that it's a string or how we spelled it or how we capitalized it, it'll autocomplete it for us. It's also a numeric value that has relevance in GameMaker. The direction now lines up to something that makes sense in GameMaker speak, with the angle being accurate for how math is done in GameMaker, how angle math is done in GameMaker. So that's a really good use case for enumerated values. We got our ammo types, we got our directions, we don't care what number this is. Although, again, we've got an array of ammo types. So if I move these around, well, I shouldn't be moving those around. I should be using the enumeration now. But I don't know. I'll be honest, this is kind of a bad example. I'm just doing my best here. Those are two fairly good examples for why you would use an enumeration over strings. Strings are bad for naming things and comparing what sort of thing you are. Enumerators are faster. I know I said earlier, don't worry about doing something because it's marginally faster. This has other benefits as well. Strings are stupid. So use enums when you can, when the string itself doesn't need to be treated like a string and you're just using it as a unique identifier. Enums are better unique identifiers. Okay, so next, let's talk about one of my favorite features and another thing that can be defined globally like enums. Let's go back here and just to let's grab our album types out of there. I'm hitting Control Tab, by the way. That's how I jump between everything here. So I can go back to enums, paste that in, and now we got our enums over here. So now let's make this script macros. Macros are super cool. You can use them similar to enums, but they have some other cool features. So let's actually replace our direction enum and let's just make it a macro. And I'll show you what that changes. This guy can stay, but we're going to do an alternate way at the same time. So I'm going to paste that guy in here, and I'm going to delete this, delete that, and we're going to convert this to a macro. So to define a macro, you do pound or hashtag for the kids, pound macro, lowercase, and then we're going to name the macro. I'm going to name mine north and say 90. So notice, no equal sign. All caps is just how I prefer to use enums. I like all caps with, if I was going to call this out more specifically, direction north. That feels redundant to me. It's kind of unnecessary. So I'm just going to say north. And no semicolon. This is the one place where having one of a few places that having a semicolon is actually not allowed at all. And I'll explain why in a second. So don't put semicolons at the end of your macro. Then we can macro the rest of these. Macro south 270, macro east 0, and macro west 180. So now let's go back to our example. And now we don't need direction at all. Just say east, north, west, and south. And I mean, this will still work because these are technically the same value, but what's really cool about macros is the way they work. So a macro is an automatic copy paste. When you run your game, when you push the play button and it builds, GameMaker is going to do a Control-Shift-F, and it's going to say anywhere you find north, case sensitive, whole word, ignore comments, right? It's going to do a full search. Anywhere you find north, I'm going to replace it with 90, right? It's a full-blown copy-paste. It's that easy, which makes sense that we don't want a semicolon here, because if we come up here, where do we use north? Oh, we use north right here. What if we replace that with 90 colon? GameMaker's not going to like that. That's not a good thing. You can't put a semicolon right there. Same with this face direction. If this were north, or you set your face direction to 90 semicolon, it's weird, right? You don't want to do it. That has some other, so the fact that this is like a copy paste when you run your game gives you a lot of power. You can do some really, really cool stuff. One of the most common things I use macros, and I have a script resource that I keep out in my helpful scripts directory that is, I bring into every project. And it is shortcuts to all of my view related stuff, all of my display, view, camera stuff that I hate typing out. So let's go let's go to our object example. Let's add a draw event. And say I want to draw a rectangle around my camera for whatever reason. I want to draw from the top left corner to the bottom right corner, regardless of where my camera is in the room right now. So I might say, draw a rectangle, x1. That's camera get view x, view camera 0, and this is going to get very long, very fast. View camera 0. This is where it gets really fun. Camera get view x, view camera 0, plus camera get view width. Holy crap, are we really doing this on every single line? Do I need 2 parentheses? Did I add too many parentheses up here? Yes, I did. Okay. And I'll copy and paste this again. Y and height. And then finally, false. I want to solve. I'm going to just draw a rectangle over the entire screen. Wow, right? Like, wow, that's a lot of code to draw a rectangle. Let's use macros to make this code just beautiful. So let's jump back to our macros. And I'm going to make macros for all of those things. Macro view is view camera 0. Macro view x is camera get view x. View. You can use macros in other macros. They do have to be defined in a specific order, I believe. I could be wrong about that, but you can. Like, I don't know if this will work. I've never tried. It looks stupid anyway. I'm using it right here. Just do it like that. Macro view y, view, and macro. Now this, again, we can combine these things. So I can get my view width, get view width, view, and then what's the right side of my screen? View right, or just R, is view x plus view width. Macro view bottom is view y plus view height, which I hadn't defined yet. And now I've got top left corner and bottom right corner. So let's go back to this code and see what that does for us. Boom. Now, that code that I just deleted and the code that we have here, exactly the same. Literally exactly the same. Because wherever we have view camera X, we're gonna replace it with this code. It's literally going to be copy and paste and replaced, find and replaced, all the way across the board, across your entire project, anywhere you type view X. So we never have to type camera get view X ever again, anywhere in our project. And that is just super, super powerful. So do this. I do this for everything. Oh, you want to get the GUI width? It's not a pixelated Pope video unless I say GUI at least once, right? GUI width, or no. Get GUI width. So utilize this. Utilize this to make shortcuts to all sorts of common functions that bring variables back. You can macro other functions as well, but it looks a little weird in my opinion. For example, macro check, right? We'll just macro check, and that's keyboard check pressed, right? You can call this check pressed, why not? Notice I didn't have the parentheses or anything. We're just gonna macro keyboard check pressed. So then I can go back to my step event and I could say check pressed. Again, it's a total find and replace. This will work, but this looks weird to me. I don't like having the red text with the parentheses. So you can do it. Up to you if you want to do it, I guess. I'm not your mom. I'm not gonna tell you what to do. I don't recommend it, but it'll work, and I don't see any reason it would be broken in the future. It's completely allowed. So just one other use of macros. All right. Last thing I want to cover in this video is I don't even know how long it's been. Was it like an hour and a half, 3 hours? What day is it? Let's talk about functions. These are super, super important. And they come in a variety of flavors. There's a number of ways to define them. Let's go over kind of my personal method and kind of rules for defining them and what they can be used for. So let's make a script resource. This is classic game maker. I'm going to say, let's see, what's one of my favorite functions? I'm going to make a draw function. I'm going to say draw bbox, right? I'm doing some testing. I want to have my object be able to draw their bbox on top of their own sprite to make it so that I know where their collision, boundaries are. So I've got a script resource called draw bbox, and within that, GM handily created a function with the name draw bbox. In old Game Maker, you didn't need that. It was kind of implied just by the virtue of having a script resource called draw bbox. But new hotness, you got to define it. I don't need to take any arguments because the object calling this function is going to have all the relevant arguments. So I'm just going to say draw a rectangle. We're doing that a lot today, huh? Bbox left, bbox top, bbox right, bbox bottom, and true. We want this to be an outline. So we just defined a very, very simple function. And I can come back to object bullet. I'm testing my bullet collisions. And I can say add a draw event, and let him draw himself, and then draw bbox with the open close parentheses. So very, very simple function. Doesn't take any arguments. All it does is it draws a rectangle that represents the bbox of the object who's running the function. So that's kind of important to note is we define this function, and similar to what we just did with macros, it's kind of a copy paste. So if I come back to draw a bbox and I were just to copy that and replace it here, that's basically exactly the same. But now I can call, it's a lot easier to just call draw bbox than type that out on every object that I want to draw the bounding box on. So a really nice thing about functions is they let you do the same thing over and over again without typing it over and over again. So if you find yourself writing the same code out multiple times, it's probably a good time to write a function that does that. But oftentimes when we run a function, actually, let me back up real fast. Why did I call it draw bbox with the underscore? You'll notice that all of my other guys, object bullet, script enums, script macros, they don't have underscores. So what's the deal with this? Why did I put an underscore here? Because, and this is kind of my own personal style, draw bbox has essentially added functionality to GameMaker. Every single object and block of code and script, everything in my game now has access to draw bbox. And in my mind, that's similar to every single object having access to draw sprite or draw sprite extended or any of these functions. So by adding this script resource as a function to my project, I have extended the capability of GameMaker in this project. I now have a function that can draw sprites, draw sprite extended, and draw bounding boxes. So I like to match the naming convention of all of the built-in functions for GameMaker because it really doesn't matter since this is globally available to every object anywhere in the project or any script or anywhere you can write code. I can use draw bbox just like anywhere in the code I could use draw sprite. Whether it'll work or not, it depends on whether you're in a draw event, but I can use it anywhere. So I match the naming convention because it makes no difference now. It should look like it's built into GameMaker because it's available. So that's a coding style choice I've made. It is possible to write functions that aren't globally available. Let's say there are only certain types of objects, like say object. Let's make a object collidable, and you know what? Both both bullets and our examples are collidable. So we're going to make these guys children, and then in object collidable, I'm going to go into the create event, and you know what? I don't need everything to be able to draw a bbox, so I'm just going to get rid of this. And I'm going to go back here. I'm going to say only things that are collidable are ever going to draw their bbox. So I'm going to make a new function here and say draw bbox, draw rectangle, same thing, same code. We're going to define it a little bit differently. I'm going to say draw bbox, and we're going to follow my normal naming convention. Draw bbox equals function. And then that'll work. Now any object that is a child of object collidable or object collidable itself, so I can go in here and say draw self, draw bbox, and then I can go into object bullet. I can just delete this. So there's a brief overview of parenting as well. Because I set object collidable as a parent to object bullet, it's automatically got this create event is inherited. So it has access to draw bbox. So when its draw event runs and it tries to run draw bbox, which again is being inherited by object collidable into object bullet, then it'll draw itself no problem. It has access to all of this stuff. So let's go back to object collidable. Why did I do this? Why did I name it and define it like this? What's the difference between this and that, right? What's really the difference between doing it one way or the other? Well, notice that draw bbox just changed colors. So that means anywhere I use draw bbox, it's going to appear orange. So what happens if I create another object or a script that has nothing to do with object collidable? What happens if I try and call draw bbox? It's orange, right? So as far as GameMaker is concerned, it's globally available. But if I try and run this function on an object that isn't a child of object collidable, well, damn, I'm fairly certain it'll break. Let's find out. Object not collidable. Hey, we've gone this entire time without actually running anything in GameMaker. That's fun. Let's find all the errors I've got. And in not collidable, I'm going to go into the draw event and say, well, let's assign a sprite. I guess, no, it's fine. Draw bbox. So not a child of object collidable because it's not collidable. We're going to draw the bbox. Are we? Let's find out. And probably a bunch of other errors because I haven't ran this game. It's probably going to yell at me for all sorts of stuff. Let's see. Oh, really? Can you not do that then? Are you really mad about this? I didn't think. Oh, hey, there we are. Line one. Let's see, and then what are you complaining against? What did I do here? West, south. Got colon expected close curly. Really? I'm gonna try you again just to be sure. Okay, so unknown object is trying to draw a B box that's in not set before reading, an object not collidable draw. So it's saying unknown object, right? It's like, hey, I'm trying to access this draw B box, but it's not available, right? I can't do it. Now, I'm totally in experimental zone, by the way. I've never really done this before. This is why I don't recommend it. If you're going to define a function on an object, I recommend doing it the other way so it's more clear that it's not available to everybody. But just to see if this will eventually define it globally, kind of as a globally available function, what happens if we go into here, we say object collidable, and then we switch, I still think that'll break. Let's just see if that'll break real fast. Yeah, still breaking. What if we do it so that collidable runs its create event before not collidable? Nope, still broken. So where in a script resource, if you say function script or draw bbox, this implies to GameMaker, which is why it goes orange, that this is a globally defined function. So that anybody should have access to. So when you define it that way in an object, you're lying to yourself. You're saying, I only want object collidables to be able to draw B boxes, but when I define it like this, it's going to turn orange no matter where I am. Now the downside. The downside is it will never turn orange, no matter where you're calling it, if you define it like this. So we go back to our draw. It's blue. It's always going to be blue. Unless you do this. Now that we've defined it with a triple backslash and an @ sign, it's func, draw B box, but it's orange over here still. So this is a big downside to GameMaker and its color coding. It doesn't know the difference between a function that's been defined, what is a function that you would hope it would turn orange when you're in the draw event of an object that has it defined and it's available to it, but not turn orange somewhere else where it's not available. GameMaker is just incapable of telling you stuff like that. So the new feather, like error checking feature, may be capable of doing something like that, but you're going to get 1,000 other warnings and errors that are going to blow up in your face and it's going to yell at you. So you're free to mess with feather. I'm not a fan, which is why I have it disabled right now. So regardless, I've just been, the other nice thing is like when you have this, you can then say, oh, does draw bbox have any arguments? No, it doesn't have any arguments. Draw bbox does accept a offset of x and y. I mean, I'm not going to use it, but now I can see when that saves. Now I can see that there's an x and a y value that it's expecting. But if I get rid of this, it goes back to being blue, which means it doesn't lie to me. Over here, now I go over here, go and click off. It doesn't know what it is anymore. It doesn't know what arguments it has anymore. This is an unfortunate downside of GameMaker. There's really no clear-cut way to handle this. There's no best practice. It's up to you. Are you calling this function from other objects, then maybe you do want to set it up as something that's global. So, I'd say function draw bbox, or no, still just keep it like that, but bring back the help text. And then over here in not collidable, I could say object collidable dot draw bbox. I don't know. This is nasty. I don't really like it. So I don't know. I've stopped doing this and just memorize it. Just have an easy way of knowing where draw bbox is defined, because even middle mouse clicking on this isn't going to take you to where draw bbox is defined. So you just kind of have to remember, how does draw bbox work? Does it accept arguments? What arguments does it accept? Does it not accept arguments? I've sort of resigned myself to just realizing I have to have this stuff memorized so that my code coloration isn't lying to me throughout the rest of my code when I try and run this function. Furthermore, if you do this draw bbox here for object collidable, and then I do this again for object not collidable, so I go into the create event, I define my own new bbox, but this one does accept an argument of x, y, or an object index, or whatever. So now I've got two function definitions for two different draw bboxes. So when I come over here, which one do I get? Do I get that one? Okay, so it's no arguments. Cool. What about if I try and use it over here? No arguments. So now you've got to fight. Which one am I trying to use? I don't know. Whichever one GameMaker decided to define last, first. I don't know. You can only have one func description per name of function. So if you've got multiple objects that have the same function or the same function name, which seems weirder than it actually is. I do it pretty commonly where an object might have an initialization function, just so like object.setup, right? How many different objects could have a setup function that does different things and accepts different things? It's not that uncommon. So I've just stopped doing that. It just isn't worth it to me. It's confusing. It's frustrating. It is a feature that I really wish I could have more control over in GameMaker, but I don't expect that to come anytime soon. Okay, one last thing about functions. Oftentimes we want functions to return a value. So there's this keyword called return. It will make a function do something and then return that value so that you can do something with it. It's like asking GameMaker to say, go do this work and just give me the result. I don't want to actually write all the code to do the work. I just want the result. The most common, like when you're looking this up and you start learning programming and they start to teach you about functions, this is the one you'll see most often. It's called doadd. This function, it takes an A and a B, and it's going to return A plus B. So to use it, you just say var sum equals doadd 5, 6. It's that return that is allowing you to do that. If you don't have a return value, just A plus B, it's not doing anything. You'll call doadd, and there's no way to get the result of A plus B out of the function. It won't do anything. You're doing an operation out in the ether and not capturing the result. So we put a return in front of it, and it's going to do that work, return the value, and then we can capture it in an equal sign. You can return anything. You can return another function. You can return a value, an array, a struct. you know, like anything can be returned. And this is super, super powerful. Let's say I do return a struct. Like this is actually kind of cool. Let's say I return the sum, which is going to be a plus b, and just for fun, let's return what you passed in. So first value was a, and second value was b. Why would I do that? It's a bad example, but let's roll with it for a second. So now when I return do add, I'm getting this structure, which means I can do this. This is super cool. You probably won't do it too often as you're getting started. As you get more comfortable with structs and return values for a function, this can be really cool. I want to capture the sum of do add. So I could do this. Result equals do add 5, 6, which is going to give us this this structure, and then var sum equals result dot sum, right? That's totally fine. Or I can do that. So do add will return this structure. And you can think of a return as kind of like copying and pasting something in place, right? Similar to what we did here. We do add gets a result, and then the sum is a result.sum. So this can be a bit mind-bending, but it's super cool to be able to call a function, know you're getting a very complex result back, a structure, something like that, and can immediately get the value out of it that you need and operate on it. So very, very, very cool stuff. And that covers functions and returns for the most part. There's always more you can learn. There's infinite complexity, but that's kind of the basics. All right, well, that was all I had to cover today. This went way longer than it meant to. Now that you're at the end of the video, maybe you should have watched this at 1.5 speed. Regardless, I'll have timestamps down in the description if you want to go back and review anything so that you can find something I covered earlier if you need to come back and refresh up on why we do certain things. Anyway, thanks for watching. Go make something awesome.